So one thing that's nice about implicit differentiation is you do not need to worry about simplification near as much, okay? So I'm not freaking out about factoring and simplifying necessarily near as much as I am with the typical problems, because these answers are going to be really ugly. They're going to have x's and y's, there's going to be fractions, there's going to be stuff everywhere. So I'm not going to freak out about your simplification. For instance, if they have a 2 in the numerator and a 2 in the denominator, and technically you could have canceled them or separated them and simplified them, I'm not going to freak out about that. I'm really just looking for you to leave the answer as it lies. So let's look at doing implicit differentiation together. Here's example 3. It says find dy dx, in other words y prime, for the equation y squared plus x squared minus 2y minus 4x equals 4. So what's the key to this? The key to this is we're going to take the derivative with respect to x of both sides of this equation. The derivative with respect to x. If they're equal, you take the derivative with respect to x of both sides of the equation. So let's start on the left. What's the derivative of y squared? Well, the derivative of y squared would be 2y, but then don't forget that y prime, chain rule. Plus, what's the derivative of x? It would be 2x, and then again, we don't need x prime because the variables match. We're taking the derivative with respect to x. Minus, what's the derivative of 2y? Well, if it was 2x, it would just be negative 2, right? But that derivative of y is not 1. The derivative of y is y prime. So this would be minus 2y prime. What's the derivative of negative 4x? Well, that's simply negative 4. That equals, well, what's the derivative of the right-hand side of the equation? The derivative of 4 is simply 0. So anything that has a y prime stays on the left. Anything that doesn't have a y prime is going to go to the right. So I'm going to subtract 2x from both sides. I'm going to add 4 to both sides. Let's see what we get. On the left, I have 2y y prime minus 2y prime equals negative 2x plus 4. Notice the whole reason that I did that is because both of these terms on the left should have a y prime, and they do. And because they have a y prime, we're able to factor it. So let's think about what would it be if I factored it. 2y y prime divided by y prime would be 2y. And minus 2y prime divided by y prime would simply be minus 2. So that's what it is when we take away the y prime. On the right-hand side, we still have minus 2x plus 4. We just solve for y prime by itself by dividing both sides by 2y minus 2. That's going to leave me with y prime equals minus 2x plus 4 all over 2y minus 2. Minus 2x plus 4 all over 2y minus 2. So that would be the derivative of the equation. We've solved for y prime. Notice again we have both x's and y's in our answers. Technically, we could do a little more simplification here. I see that we could factor out a negative 2 on top and a 2 on bottom, and those would simplify. But I'm not looking for that. I truly don't care at this point in time. I just want you to solve for y prime. It's hard enough as is. Let's continue on to the next example. It says example 4. Find dy dx, again y prime, for the equation xy squared plus 4xy equals 10. I see a lot of product rules we have to do here, so this one's going to be a bit messy. Hang with me. We're going to do each part at a time. All right, so we have xy squared plus 4xy equals 10. Let's do each piece at a time. So the first piece that I want to look at is xy squared. Again, this is going to require the product rule because it is x times y squared. So this would be x, the first, times the derivative of the second. Well, the derivative of y squared is 2y, then we need that y prime in there. That's first times the derivative of the second, plus the second, which is y squared, times the derivative of the first, which is just the derivative of x is just 1. So that is the derivative of what I underlined in red. First times the derivative of the second, plus the second times the derivative of the first. Let's do the next part here. What's the derivative of 4xy? Well, that's another product rule. You've got to think of it as 4x is one function, y is another function. So using the product rule, we would have the first, which is 4x. Let me make sure that clearly looks like an x, times the derivative of the second, which would be times y prime, plus the second, which would be y, times the derivative of the first. Well, the derivative of 4x is just 4. So there's the product rule for the second part. Now we have an equal sign, and now we need to find the derivative of 10. So again, what we're doing with this is we're finding the derivative with respect to x of both sides of this equation, right? So never forget to find the derivative of the right-hand side of the equation too. The derivative of 10 is quite simply 0. I'm going to clean this up. This first term would be 2xy y prime plus y squared. Then I'd have plus 4xy y prime. Sorry, 4xy prime. Be very careful there. Plus 4y, and that equals 0. Again, the whole point of this is solve for y prime. So everything we can on the left, we're going to, with a y prime, we're going to keep on the left. Everything else, we're going to move to the right. So I'm going to subtract off a y squared from both sides. I'll also subtract off a 4y from both sides. So minus 4y. Let's see what we have when we do that. On the left, I still have 2xy y prime plus 4xy prime. On the right, I have a negative y squared minus 4y. Why did I do that? Again, I did that because both terms now have that y prime on the left, which means I can factor out that y prime. So factoring out that y prime, I'll have y prime times, well, 2xy y prime divided by y prime. Take away that y prime, you're left with just the 2xy. 4xy prime divided by y prime. Take away that y prime, you're left with 4x. That equals negative y squared minus 4y. We need to solve for y prime by dividing both sides by everything else. So that's the 2xy plus 4x. Divide both sides by that 2xy plus 4x. When we do that, we end up with our final answer. Again, we do not need to simplify any further than this. Y prime equals negative y squared minus 4y all over 2xy plus 4x. Again, I definitely see more that we could do there. For instance, I see we could factor out negative y on top. You could actually factor out y squared minus 4. Well, potentially, there's different things that you can do with factoring and simplifying. On bottom, I see we can factor out a 2x. I don't care. Don't waste your time. Don't simplify any more than this. This is most certainly all you need to do on the problem, so don't try to do more. Okay, let's move on to the next one. Find dy dx for the equation natural log of xy plus 5x equals 30. Again, what we are doing is we're finding the derivative with respect to x of both sides of this equation. Because they're equal, their derivatives have to be equal. So let's do this part by part. Again, this first part's going to be nasty, the natural log of xy. Let's think about the derivative of natural log of xy. Well, the derivative of the natural log of anything would be 1 over whatever's on the inside times the derivative of the inside. Okay? Plus 5 times, and by the way, the derivative of the inside, that derivative xy prime, that's going to require the product rule. So maybe let's just, before we move on in the problem, maybe let's figure that out. What's the derivative of xy prime? That's x times y, isn't it? So the derivative of that would be the first, which is x, times the derivative of the second, which would be y prime, plus the second, which is y, times the derivative of the first, which would be the derivative of x. The derivative of x is just 1. So the derivative of xy is xy prime plus y. That's the product rule, right? Okay, let's continue on in the problem. This is just the red part. That's all we've done. We still need to come in and do the black part here. What's the derivative of 5, or the blue part? I just underlined it in blue. What's the derivative of 5x? That's simply 5. Don't forget to take that derivative of the right-hand side of the equation. What's the derivative of 30? Well, the derivative of 30 is 0. Okay, so this is going to look nasty, but what I'm going to do is I'm going to distribute 1 over xy to each one of those terms. So bear with me. We have 1 over xy times xy prime. So that would be xy prime over xy. And then we have 1 over xy times y. So that would be plus y over xy. Then we have plus 5, and that equals 0. I'm going to do some simplifying here because I see the x's simplify in the first term. I see the y's simplify in the second term. So what am I left with? I'm left with y prime. Sorry, let me change my color. I'm left with y prime over y plus 1 over x plus 5 equals 0. So I need to solve for that. How am I going to solve for that? Well, I could subtract 5 from both sides. I could subtract 1 over x from both sides. When I do that, I'd end up with y prime over, change my color, 1 second. Y prime over y equals, well, I'd have a negative 5 minus a 1 over x. Okay, again, I could sit here and I could get a common denominator. I could factor out a negative. I could combine those terms. I can make it look pretty. I just don't care about that. So what I'm going to do to both sides now is I'm going to multiply both sides times y. When I do that, I'd end up with y prime equals, this is not nice, this is not pretty, and I don't care, negative 5 minus 1 over x in parentheses times y. A lot I can do to clean that up, but I just don't care, so I'm going to leave it in that form right there. Let's go ahead and look at the last problem on the page. It says find dy dx for the equation x squared y minus e to the y minus 4 equals 0. Again, all we're doing is taking the derivative of every single term with respect to x, both sides of the equation, derivative with respect to x. Let's look at our first piece. What's the derivative of x squared y? Hopefully you're getting used to this by now. We've done the product rule on virtually every problem. So this would be the first, x squared times the derivative of the second, which would be y prime, plus the second, which would be y, times the derivative of the first, which would be 2x. That is just the red part. Now let's consider the blue part. What's the derivative of e to the x? Well, it's e to the x. So what's the derivative of e to the y? Copy and paste. It'd be e to the y, but then remember we need that y prime. So there's the blue part right there. What's the derivative of negative 4? Well, that's just 0, so I'm not going to put that there. And what's the derivative of 0? That's also 0. So I'll put that on the right-hand side because we do need that over there. Okay, so clean it up just a little bit. It would be x squared y prime plus 2xy minus e to the y prime equals 0. Every term with a y prime stays on the left. Every other term moves to the right. So I'm going to subtract off 2xy from both sides. When I subtract off 2xy on the left, I'd be left with x squared y prime minus e to the y prime equals negative 2xy. Why did I do that? Because now every single term on the left should have a y prime, so I should be able to factor it out. Factor out that y prime. In the first term, x squared y prime, take away the y prime, you'd be left with x squared. In the second term, e to the y prime, take away the y prime, you're left with e to the y. And that equals minus 2xy. So that's the factored form of it. We divide by both sides by x squared minus e to the y. X squared minus e to the y to solve for y prime. And I'm left with y prime equals minus 2xy all over x squared minus e to the y. And there's our final answer. Again, I don't care if we could simplify. I don't care about anything. I've solved for y prime. I'm done.